a wonderful Kubernetes cluster. It's stood up. It's protected. You're running network policies in it. That's all great. But how do you get in and out? How do you now you make this your services available to external resources, external users, external services to access the capabilities that you're now providing from within the cluster, and just as importantly, how do you get out of the zoo? How do your pods and your services reach out of the Kubernetes cluster and connect to services external to the cluster? That's what we're going to spend some time talking about today. I'm going to first start off with talking about Kubernetes services. So if we go to Kubernetes services, I'm going to initially talk about cluster VIP. And I spent a reasonable amount of time discussing what cluster VIP was the last webinar series. I'm just going to do a quick last webinar. So I'm just going to do a quick review of that. If you want more details, please go look at the previous webinar, and I go into it in semi-excruciating detail. So Kubernetes provides a logical service abstraction for a set of endpoints. So basically, when you decide that you want to offer a service off of a given set of pods, be one or more pods, you define a service. And you then map that service to a label on the pod. So you basically say this service will be provided by all things labeled LDAP server. Okay, that's now an LDAP service or whatever. So you use Kubernetes labels to identify workloads that should be part of a service. And then you define a service object in Kubernetes that will then expose that service to the broader community, make it discoverable via DNS, which we've talked about a little bit before, as well as making that service exposed via some networking mechanism. So by classical or original Kubernetes behavior, this was done via something called cluster VIP and using something called kubeproxy. Originally, kubeproxy was an actual proxy that ran on every host that answered for all the services that Kubernetes was offering and would then redirect the traffic to a pod that was serving that service. Today, it's just IP tables rules, and that's moving to IPVS instead of IP tables. But interesting thing here, unlike a lot of other network CNI plugins for Kubernetes, Calico functions seamlessly with standard kubeproxy. We don't make you replace it. We just work with kubeproxy. So let's take a look at a very high level how kubeproxy works, otherwise known as cluster VIP. So with cluster VIP, what's going to happen, you can either create a service YAML, like I said, that hooks a label in a deployment or a set of pods, or you can just use a kubectl expose. In this case, we're going to run this in Project Pink's namespace, and we're going to say that the Nginx deployment will be exposed as a service and we're going to expose port 80 on that service. So what's going to happen is kubeproxy will get notified that there is a new service created, and that is it's going to pick that up and it's going to get a list of all the things that match that service. In this case, everything that's a deployment in the deployment Nginx in the namespace Project Pink. And it's going to create NAT rules for that. So it's going to, when you create a service using service VIP, Kubernetes will create a service IP, a virtual IP for that service, and will come out of the service IP range, and we'll create that virtual IP. No pods will be getting that address. What's going to instead happen is we'll catch that IP address on the interface, physical interface, on all the hosts in the Kubernetes cluster. And there'll be NAT rules that will then rewrite that service IP address to one of the destination IP addresses of the IP address of one of the pods serving that. And that's going to be done in a round-robin fashion. And kubeproxy is responsible for making sure that the pods are up and answering services, etc. And each kubeproxy on each node will independently then load balance across those. So what's going to happen is, in this case, the pod that's IPA3 is in the pink namespace, project pink namespace, it's going to try and connect to the service IP of the Nginx deployment. The NAT rule on worker X, which hosts IPA3, will see that traffic destined for that service IP, and it will rewrite the destination address to a pod that's offering that service, in this case, IPv3's pod. And so when traffic leaves worker X, it will be addressed to IPv3, not to the Nginx IP address. And then standard routing or whatever you're using for CNI will pick that packet up and forward it to the right destination. In this case, in Calico case, it will be routed to worker Y, which will then route it to the IPv3 interface. So that was the way things worked when we first started with Kubernetes. Now, over time, we've created a number of other services that are or capabilities of exposing services. Sorry. So let's look at what some of the service types are. The first one's a null service type, none. So let's say you've written your own Kubernetes controller. So a Kubernetes controller is a piece of code, usually runs as a pod or a deployment itself, that watches the Kubernetes API for specific objects and then does something on those. So let's say you don't like any of the service types that Kubernetes provides for you. You can write your own controller that will do something interesting when you define a service. So in that case, you don't want any of the existing controllers in Kubernetes for the different service types to do anything with your service definition. You just want to say this thing is a service, and then your controller could pick up on that and do something with that. So none is basically just a ability for you to call out and do something unique. Cluster VIP we just talked about, that instantiates a kube proxy instance and assigns a cluster VIP to one or more pod IP addresses, and away you go. We just talked about that. Node port is another mechanism, and for those who are using overlay networks, etc., where the IP addresses in the cluster may not be accessible to the outside world, meaning your cluster or your service VIPs aren't accessible, you can basically assign a port on every host to represent that service. So in this case, if you did a node port in our previous example, the Nginx service might be made available on port 3080. And in that case, 3080 on every node would then get NAT rewritten to port 80 on one of the Nginx pods. And this uses host addresses, and host addresses theoretically should be reachable outside of your cluster, so that works. Problem with this is every service will now have a unique port address. So now you're going to have to deal with service discovery not using standard ports. So let's say you're going to expose this as an external service. You have to tell people to go to http://myservice.example.com:3080 or some other service discovery mechanism to make this work. So that's and you can only have a single, you can't have any port conflicts here because those ports are exposed on each host. So this makes service discovery a little more difficult, especially if you're interacting with humans. DNS, and you use server records, but a lot of DNS services, a lot of web browsers, for example, don't honor server records. So this is a suboptimal, but it's a quick and dirty. Load balancer will create rules on the supported cloud provider's load balancer. So basically what this does is says, Kubernetes is going to do anything specifically, it's going to program an external load balancer to do the service exposure. External names, I think a lot of people get this wrong. People think this is assigning an external DNS name to a given service, and that's incorrect. What this is taking an external service and giving it a name within the cluster so the cluster can DNS resolve it. I've done a blog post on DNS, and I believe we did a webinar as well where we talked about how you can give pods or services an external DNS name. So again, go back and look at the previous webinar, and we talk about DNS facilities that allow you to attach other names, non-cluster names, to given Kubernetes services. So let's talk about how we already did this one. That's a repeat slide. So let's go to Kubernetes Services node port. So node port, what you're going to do here is you're basically going to say that this service, I'm going to call it Nginx service, is served by all pods or deployments that are labeled app Nginx. It's a type node port, which triggers this behavior, and the Nginx serving pods will be listening on port 80, but what you want is the node port to be 30,080. So in that case, worker X, worker Y, even the masters, will write a NAT rule that says anything inbound on port 30,080 will get rewritten to one of the serving pods, again in this case maybe IPv3's IP address port 80. So you're going to do a destination IP and port NAT on each worker or master to send the traffic to one of the pods that's serving the traffic. So that's a node port.
So Christopher, I think on this diagram there was some confusion around what the items were. What's a pod, what's a service? And so you just explain that.
Sure. So in this case, the IPX, IPY, IPW are the IP addresses of the workers and the masters. The pods are the boxes that are on top of the gray. So IPA1 is the IP address of pod A1, pod A2, pod A3. So those little orange boxes with a little caret on them are the actual pods themselves being run as pods on a given worker. The gray box is the Linux kernel, and inside that's a routing table. Kubeproxy, which isn't really active here, is shown on the side, as well as the kubelet. So what this is showing, if you follow the dashed line on the magenta line on this, is traffic comes in from somewhere. It could be outside the cluster, it could be coming from one of the pods on worker X, but in this case it's coming from outside the cluster. And it gets delivered to worker X on worker X's IP address, but is destined for port 30,080. The NAT rule that's gotten written into worker X's kernel basically says anything coming in on port 30,080 should be sent to one of the pods offering the Nginx, labeled app Nginx, and port 80 on that pod. So in this case, the NAT rule on worker X decides to load balance this to IPv3 or the pod B3 on worker Y. So it will rewrite its IP address, destination port 30,080, to IPv3 port 80 as the destination, and that the traffic will get delivered to the service, or to the pod offering the service. That answer the questions?
Yeah. Yep.
Cool. Next one is a load balancer service. And in this one, there's a number of load balancer services that are available within Kubernetes. You could write others as well. Mainly these are focused at cloud load balancers. So the load balancers available in Google and Amazon and Azure, IBM, etc. So what this is basically saying is when you create a service, you want this to be accessed via the load balancer in your public cloud infrastructure. And there's then some configurations about what IP address you want this, the cluster IP, what IP address you want the service to have, otherwise we'll get assigned one, what the port number that the load balancer should direct the traffic to, again, what pods are offering the service, and whatever else you need to do to configure the load balancer ingress. What's going to then happen is whenever the pods offering the service change, i.e. you spin up another pod offering the My App service, or you, in this case, or one goes away, the load balancer in the public cloud will have its inventory changed. So Kubernetes, through a operator or controller will update the cloud load balancer's configuration and tell it about the new IP addresses offering that service as those pods come and go. So in this case, the traffic is being handled externally, and you're relying on the load balancer to send the traffic to the right pod. In this case, it knows IP A3 and IP B3 are offering the service, so anything coming in to the load balancer for that service IP and potentially that IP address, if necessary, or port, will then be sent to the IP addresses of IP A3 or B3 on port 9376. So you're relying on an external load balancer. What if you're in private cloud? So in private cloud, you don't have one of those cloud load balancers, but there are lots of people who want to be doing this. So one of the things you can do is there is a project called MetalLB, and it is a load balancer that's actually deployed as a Kubernetes deployment. So MetalLB is another load balancer that's supported by Kubernetes, or you can plug into Kubernetes, and it's running its software pods on hosts. So basically, by MetalLB as Kubernetes, you can lifecycle it through Kubernetes. You can auto-scale it like you would Kubernetes, and it can run in L2 or L3 mode, which basically means that you can have tell Kubernetes to auto-scale this. You can have a MetalLB load balancer that's acting as your load balancer. Kubernetes will grow it or shrink it as scaling requires, and all those MetalLB instances can announce the service IP address out to your infrastructure. So this is using the same kind of technology we use in Calico, using BGP, which allows you to actually have then your load balancers auto-scale and tell your router infrastructure in your private cloud, your data center border router, your top of rack switches, etc., which load balancers are currently available and serving this service. So now your load balancers can scale, which in turn are scaling your service. This is actually a pretty powerful thing. It's pretty much a Kubernetes native way of doing load balancing. You can do this also in public cloud, but public cloud has load balancers already. So this really gives you the same capabilities you have in public cloud on private cloud. So,
yeah, we had a question on, I believe it was on the previous slide, where the person asked about the My Service configuration containing both ingress, node port, and type. Is with the load balancer, can all of them be the same configuration?
So it depends on the load balancer and depends on how you want to configure this. Node port you don't necessarily need. The target port is usually the port of the service. The port is the thing that you want to offer the service on. So yes, if you don't need to remap a service port to the port you want served, yes, they can all be the same thing, or you can just drop them out and then config. And there's pretty good documentation on the Kubernetes website about how these things get configured, and more specifically, examples. If you go to AWS's documentation or Google's documentation, they'll have documentation on how to configure Kubernetes load balancers to use their load balancing service. So there is yet another way to get into your cluster, and if you're using Istio, this is an intriguing mechanism. So you're already using Istio for all your east-west service mesh, right? So if you're using Istio, you're using it for service discovery and service meshing of your services, talking to each other within the cluster. It gives you automated back-offs and circuit breakers, retry automation, blue-green deployments, lots of metrics and controls on all those API calls. But if you're using a north-south load balancer for traffic coming into the, you're getting a different set of capabilities. They may not give you all the same capabilities. They may give you it in different mechanisms, etc. So you now have to configure, sort of for the same API endpoints, a different set of mechanics for east-west consumers versus north-south consumers. It might be nice to be able to say, I don't care where the consumption's coming from. I don't care if it's within the cluster east-west, or if it's coming from another cluster, or if it's coming from an external user. I want the same mechanics. I want the same retry, blue-green deployment. I want the same metrics, etc. So you can actually use Istio as an ingress gateway. So it's yet another object, and it happens to be an Istio object, not a Kubernetes object. But I took this diagram from okay. So so in this case, what's actually happening is traffic comes into whatever your cloud load balancer, again, this could be MetalLB, this could be, if it's coming from the outside, it could be coming from one of the public cloud load balancers, etc. And then it's going to get delivered to a service instance called the Istio Ingress Gateway. So that's a virtual IP, just like any other service that is been configured as a service in Kubernetes. It's an Istio Ingress Gateway service. So it's going to go to the service IP. It will then get directed via all the mechanisms we talked about before to an instance of the Istio Ingress Gateway. That Istio Ingress Gateway is defined by two objects. It's a virtual service object and a gateway object. And then that Istio Ingress Gateway will do all the things that you love Istio for, collecting statistics, doing blue-greens, etc. And eventually will deliver the service, the traffic to an instance or a deployment of your application, a specific pod of that application. So we'll talk about what those objects look like a little bit. An Istio gateway service is comprised of one or more gateways, and it's defined, as I said, as an Istio gateway object, one or more of those, so you can actually have multiple Istio gateway objects, and a service object which defines the routing rules and points to the underlying service. So the gateway object defines what ports and hosts we're listening for, and then the virtual service object defines how you route that to a final destination. And this is what some of the objects look like. A gateway object, it's an Istio Ingress Gateway. It's going to be listening on port 80. It's going to be listening on HTTP. And it's going to be listening for traffic destined for http://bin.example.com. If something else comes into that Istio gateway object for foo.example.com, it's not going to get served by this gateway. You can have more than one gateway object pointing to the same deployment. The service basically says for that given host, http://bin.example.com, what are its gateways? This is what links you back to the gateway service that we just did, the HTTP bin gateway. And saying for HTTP, you're going to match URIs prefaced by status or delay, and you're going to route that to pods on port 8000 with the label host HTTP bin. So if something comes in for a prefix cust record, it's not going to get routed. So you mix the virtual service and the gateway object, and that's how you then bring external users or external services into your Istio infrastructure in your Kubernetes cluster. So we've talked to this point about how you get stuff in. That's great. We're not Hotel California here. So what I wanted to be able to do is get out. This could be, your pods need to be able to download, or infrastructure in your cluster need to be able to download the latest objects in a Docker repo or in a Quay repo or wherever else. You may need to be able to connect to an external service to make a database query, etc. We've talked before about how you can secure all that traffic using host objects and network sets in our webinars, and you can look at our previous webinars, figure out how to secure it. But really, reality, there's a couple of rules here. If you're in an overlay network, so if you're using something that tunnels all of your Kubernetes traffic across some other infrastructure, you're going to need to NAT your traffic because no one else knows what your IP addresses are. And two, you're going to need to have encap, de-encap gateways. So you're going to have something at the edge of your network that will encapsulate and de-encapsulate the traffic in and out of your Kubernetes network. These can become single points of failure or choke points, but people do run overlay networks, and that's just a factor of overlay networks. So you will need those capabilities. If you're not using an overlay infrastructure, such as Calico and some of the other solutions that are out there, you don't need that egress gateway. You don't need that encap gateway because there is no encapsulation to add or remove. You may need NAT if you're using private addresses. So say you want to be able to get to the outside world to pull down something from Quay, but you're using 10 net addresses within your cluster for your pods or your hosts. Then you need to do NAT. You can do that NAT in a very scalable way using the pod's host address. So basically you do NAT to anything exiting your cluster, anything going to an external address, you NAT it at the host. Now that assumes the host's IP address is usable is understandable by the destination. So within your enterprise or public internet basically means your host must have addresses. And again, this can automatically be configured if you're using Calico as part of our IPAM configuration. Or you can do NAT right at the edge of the cluster using some kind of NAT gateway on your border routers, etc. Because Calico is a full IP stack implementation, if you're using something like Calico, you can actually use routed IP addresses for your pods. And we do have customers who take their pods that are going to be accessing external resources or exposed to external users. You can actually assign them public addresses and we'll route those out. So in that case, you need no NAT. You just are giving them addresses that are publicly understandable, and then you use Calico policies to secure those, much like you would secure anything exposed to the public internet with a firewall. So if your encap rules are, if you're using an overlay, you have to have an encap, de-encap gateway, hopefully more than one of them, hopefully auto-scaling. If you're not in an overlay, you still may need to do NAT or not, depending on address space you're. And if you're doing NAT, you need to make a decision if you want to do that at the host layer, which is more scalable, but means the use of more public addresses, i.e. public address on every node, or every host, or at least routable address on every host, or using a single public address at the border of your infrastructure. So that's how you get out, that's how you get in. So now we've actually are doing something useful with our cluster that we've been building. With that, we've reached sort of the end. If anyone has any questions, otherwise I'll turn it over to Michael.
Anybody has any questions, please go ahead and ask them through the question interface. I have a question. There were, and I am not clearly as technical as our answer as you, but there seems like there are a lot of options out there. There are many ways to do this. And I know that probably depends on the situation and the application that you are talking about. But is there one kind of gold standard best practice that you would say, listen, if you can go with, or is it just too many choices and just depends?
I think it really depends. I think if somebody's just getting started with Kubernetes and they're really just looking to expose services within the cluster VIP is a really easy way. There's no other pieces involved. It's all ships with what's in Kubernetes. If you're using Istio already, Istio Ingress Gateway is really appealing. So that means you don't have separate tooling for north, south, east, west. If you're going to start using Kubernetes in anger, you probably should be looking at some kind of load balancer that's Kubernetes aware. So then I start thinking about one of the cloud load balancers or Metal LB. You might mix and match these. So it sort of depends on where you are in your cycle. But if you're just starting out with Kubernetes, kubeproxy is a pretty painless way of getting started. The others all require you to do something else. But that something else brings benefits if you fit that profile. As far as outbound, it's really nice to do NAT on the host, assuming the host has an address that's viable or valid for the destinations you're trying to reach. Otherwise, NAT at the cluster edge or at the border is usually the simplest thing to flip on. And to simplify matters, I mean, your job to build a Kubernetes cluster is usually to ship applications or make it possible for you to deploy applications. It's not to be a network plumber. So you should try and make the networking as simple as possible, such that you don't end up spending a lot of resources figuring out when something breaks how your networking works. So keep the network simple. Keeping the network simple usually means, among other things, trying to avoid encapsulation. Encapsulation always brings with it, you now are managing two networks, the overlay network and the underlay network. So if you can remove layers, that always makes things simpler. So try and avoid using overlays unless you really like diving into packet forensics. So, pick something easy from a networking standpoint and try and use as few of the knobs as possible, at least at your starting point.
We had a couple other questions come in. So this one is around Calico. So should all Calico service endpoints go through an existing firewall when traffic is API-based and needs to call out? Existing firewalls are an interesting problem with Kubernetes because the IP addresses of the pods offering the service are, so if for inbound, firewalls are a bit of a problem because the IP addresses of the destination are dynamic. So unless you can update your firewall rules in Kubernetes times, that's a bit of a problem. That's why we have Calico network policy. You can certainly send traffic out through a firewall for inspection, etc. But again, with Calico network policy, natively we have egress rules. So you can have rules that say only things labeled Bob are allowed to connect to the outside world, or only things labeled Bob are allowed to connect. Maybe you only want your DNS servers to talk to some higher level resolver like 8.8.8.8 or 1.1.1.1. So maybe you say only things labeled DNS server are allowed to connect on port 53 to 8.8.8.8. And then in Calico policy, if anything else tries to connect to 8.8.8.8 on port 53, it would be blocked. So you can do policy at the Calico layer, but you can certainly also have a firewall at the edge for additional protection. But again, remember that the IP addresses are going to be very dynamic. So you probably want to think about that firewall more as a fairly coarse filter catching things that just shouldn't be coming in. You never want telnet coming into your infrastructure no matter what, so just block port 80 to all destinations, for example, at your border firewall. But I hope that answers the question. A more detailed answer would probably require discussion about your architecture and what you're trying to achieve. Mm-hmm. We have a question about non-HTTP ingress and egress traffic. So
non-HTTP ingress and egress traffic, you're not going to use Istio proxy, Istio ingress gateway because, nor are you going to use Kubernetes. One I didn't talk about was Kubernetes ingress controller. Drop that one off. Those are HTTP, HTTPS, possibly gRPC only, but you could still use load balancers. You can still use service VIPs. You still can use node port. So you could use a load balancer in MetalLB or load balancer in AWS or GCE load balancers for a non-HTTP, HTTPS gRPC traffic.
Okay. Well, that looks